Hi, welcome to our next lesson. We're going to be dealing with diameters and chords. The objective is how do we recognize and use the relationships between diameters and chords. So we're going to be learning 3 theorems dealing with diameters and chords with their relations. So the first theorem dealing with arcs and chords, it says in a circle or in congruent circles, 2 minor arcs are congruent if and only if their corresponding chords are congruent. So the 2 chords that we see are AB and CD, which I'm going to highlight. So we have AB and CD, they're both chords. And I'll just put another one. That's fine. So they're both chords. Now, their arcs that is created by the chord, which I will highlight in green, is AB and CD. So for those 2 minor arcs, if they are congruent, and I'll mark that as congruent, if these 2 are congruent, then the chords will be also congruent. And then I'll just reveal this. So if chord AB is congruent to chord CD, then arc AB is equal to arc DC. So that's what the first theorem is talking about. So we're going to do an example based on that, and I'm going to make this wider. So it says if DE is congruent to FG, and angle EBF is equal to 24, and arc DFG is a semicircle, find angle FBG. Alright, so semicircle we know is 180, and then the angle that we're looking for is going to be X. So based on the information that was given, I marked that ED and FG are congruent, so we have the little tick purple marks. The X, which is FBG, that's what I'm looking for, and they also mentioned that angle EBF is 24. And they also said that arc DFG is a semicircle, that's 180. So I highlight that in yellow, and that's an 80. So I have all the information I need. Now I start working on finding that missing angle. So what would I do? So the first step, or first thing that I would do, mention to myself that FG and DE are chords. Okay, so they're chords. So then that means that FG and DE are congruent, because they mentioned that they are congruent. And because they are congruent, now this is going back and forth, it's tiny, but since they are congruent, then that means arc FG and arc DE are congruent because FG and chord ED are congruent. So this is going back to the theorem that we just learned. So they're both congruent. Because they are congruent, then that means the next thing that we would do is they both will have the same measure. So let's go back to angle EDB and GBF. So those 2 angles, they're going to have the same measurement because arc FG and ED are congruent. And remember about central angles? EBD and FBG are central angles. And the relationship between central angles and their arc measure is that they're equal to each other. So that's mean whatever arc measure for FE and ED, that angle FBG and DBE will also be the same, as mentioned here. So they said that angle E FBF is 24, right up there. That's a central angle, so that means arc EF will also be 24. And I should mark that up, so that way we can see what's going on. I know this is tiny, so bear with me. Use the calligraphy pen for this one. So then that EF is 24. Alright, so now that we have that information, now we can start solving. So I know that my semicircle is 180, so I'm going to add up whatever I will get for FG and ED. They're both going to be the same. So x and x, 2x, and plus the 24 for that arc measure, based off of the central angle being 24. So x plus 24 plus x equals 180, and then I solve, and I found it to be x equals 28. So then that means that angle FBG is going to equal 28. Because the arc is 28, then that angle, that central angle, which is right here, is going to be also 28. So again, this is based off of the first theorem. If the chords are congruent to each other, then their arcs that are formed by it will be congruent. And those arc measure is going to equal the central angle, because the central angle equals the arc measure that is created by it. So these are all information you learned from the previous lesson. You're just applying it again with the theorems. Right. Next one. The second theorem says, in a circle, if a diameter or a radius is perpendicular to a chord, then it bisects the chord and its arcs. So we have a picture here. The diameter they're talking about is AB or BA. The radius is CA. I chose CA because we're looking at the chord that is TV. Notice how BA cuts right through TV and it creates that perpendicular line. You've got a vertical line and a horizontal line. The horizontal line is the chord. The vertical line is the diameter. They intersect at a right angle. So when that happens, that means that TU and VU are going to be congruent to each other. So I'll mark that up. So this will be congruent to this. And arc TA and arc AV are going to be congruent. And then I'm going to put that in the highlighter. So then this and this, and then mark it up with another color. So yeah, so this happens when you have a diameter or a radius. So let's say this was just the radius, AC, bisecting TV. You know what bisecting means. Bisecting means cutting two segments, two lines, two whatever it is, into two congruent parts. So, and since BA is going right through the center of the circle, so whatever is in the circle that intersects with it, providing that it's a horizontal line like a chord or another diameter, it will bisect it into two congruent segments. So that's what theorem 2 talks about. A diameter is perpendicular to the chord, and it will create two congruent segments, and also the arcs will be congruent. All right, let's go on to an example based on that. It says that circle O has a radius of 13 inches, which is right there. OC and OB are radius because they start from the center and they touch a point on the circle. Then they say that a radius OB is perpendicular to the chord. You know, perpendicular means 90 degrees. Perpendicular, and then CD, which is the chord in green, is 24 inches long. They want us to find, if they say if angle CBD, I mean not angle, sorry, arc CBD is 134. So I'll mark that up, 134. Actually, let me highlight that so that way, let's See what we're looking for? Good. So that arc CBD is 134 degrees. They want us to find arc CB. So that's a piece of CBD. So how do we end up finding what that is? Let's go back to what we know based on the theorem. We know that when a radius and a chord intersect, they create a right angle, and that radius bisects the chord into two congruent segments. So that means, chose the wrong one. So that means that CX is going to be congruent to XD, and arc CB is going to be congruent to arc BD. Alright, so let me move this stuff over here. So OC we mentioned is a radius, so it's also 13 inches. We also said that radius OB bisects arc CBD, so that means arc CB and arc BD are going to be congruent. So then what do we do? The 134 for that whole arc divided by 2, and we get 67. So then that means arc CB is 67. Again, if you know that the chord, the radius is bisecting the chord into two congruent segments, and its arc into two congruent segments, then that means you just divide by 2 and you get your answer. Nothing to it. Alright, next one. The third theorem says that in a circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. So we have G, which is the center of the circle. We have GE and GB, which are both 10. We have GA and GF, which are radius, because they start from the center and go to touch a point on the circle. And notice that the chords that are 10 whatever units away from the center, so they are equidistant. So I'm going to mark that up so that way you know what we're dealing with. So this is congruent to that. This is also congruent to each other, and that means the chords are going to be congruent to each other also. So then, like it says, if EG is congruent to BG, then FD, chord FD, is going to be congruent to chord AC. And just to make this clearer, so I'm just going to highlight the chords. So that's this. And then the measurement that they were talking about, I will also highlight that in green. So EG is 10, that's 10. It's equidistant, so whatever is equidistant from the center of the circle, and if both of the distances is congruent, then the chords are going to be congruent. So that's all the third theorem is saying. You got two chords, they're congruent if and only if they are equidistant from the center. Equidistance mean equal length, equal distance. Okay, so we're going to do an example based off of this. Again, this is one of those long ones. We said that chord AC and DF are equidistant from the center. If the radius is 26, they want us to find AC. So that's a chord that they want us to find, AC. And I'm going to make that in green, so that way we know what we are working with. Right. So I marked up everything up. Radius, so we have GA, GF is a radius, so they're both going to be 26. Radii in the circle are all congruent. The equidistance, GE and GB, are 10. So the chords, we know they're going to be congruent. So I'm going to mark that up with green. So we know what we're dealing with. Okay, so let's start trying to find AC. So what did I write here? So this is if you extend GB to touch the circle at a point, let's say P. So I'm going to extend GB. Use this color. And then I'm going to make that point P. So let's say we extended it, so it's going to be touching a point P. Then it will become a radius. So GP is a radius. Next thing, since the radius is equal to 26, then GP is also 26. So that whole length there is 26. Alright, so next one. Since AC is a chord, and GP is a radius, according to the theorem, they are perpendicular. So then I'm going to do the little perpendicular mark right here to show that GP and AC are perpendicular to each other. The only reason why I extended G to all the way to P, to show you that this is a radius that is intersecting with the chord, and going back to the theorem, when you have a chord and a radius intersecting, they create a right angle. Alright. Now, since we know that going back and forth, we need to look for AC. But in order to find AC, notice that we have the measurement for AG, we have the measurement for GB, which is 10, AG is 26, and we have AB that we don't have a measurement for. But what we know is, since the radius is bisecting the chord AC, that means whatever we find for AB will be the same for BC. And then we can then find the overall length for AC. So we know this is a right triangle because the radius intersects with the chord. So now we're going to do the work, and I'm just going to make this smaller so that way this doesn't drive me crazy. So in order to find AC, we draw the triangle. So I draw accordingly to what was here, the information I was given, the 26 for AG, 10 for GB, and then we're looking for AB. So I do all of that work using the Pythagorean theorem because that relates to the triangle. This is small. So again, relating to that triangle, and then I found it to be 24 for AB. So let's go back to the picture. So if AB is 24, if this portion is 24, and we know that this bisects, GB bisects the chord into two congruent segments, then that means this is also 24. So since they want us to find AC, we need to just double it up, or add the 2, which would give us 48. Like I said, based on the theorem, since the radius bisects the chord, BC is congruent to AB is congruent to BC. So therefore, 24 times 2 gives you 48, and we found our measurement for that chord to be 48. So again, we're taking it, when it comes to tackling a problem like this, take all the information that they give you and everything that you've already learned, put it together, work piece by piece, and then get to your final answer. Right. Oh, we've reached the end, so going back, we learned things, the 3 theorems that deal with diameters and chords, or radius and chords. So the first theorem, it says that in a circle or congruent circles, 2 minor arcs are congruent if and only if their corresponding chords are congruent. So if the chords are congruent, then the arcs that are formed by it are also congruent. That's the first theorem. The second theorem is in a circle, if a diameter or a radius is perpendicular to the chord, then it bisects the chord and its arc. So you have a diameter or a radius cutting through the chord, it's going to get 2 congruent segments, and two congruent arcs. And then the third theorem states that in a circle or congruent circles, two chords are congruent if and only if they are equidistant from the center. So if they have the same distance from the center, then those chords will have to be congruent. Right. So we did applications dealing with those three theorems. Again, it's everything that you know about circles, know about radius, know about Pythagorean theorem, because we have to find segments within that circle if there's a right triangle in it. Or everything that you've learned from before, you're just applying it more into the circle and finding answers for chords and other segments that are in the circle. Right, if you are having any difficulty with this, you know that you can always email me, and I can always provide you more examples with step-by-step explanations to get to the answer. All right, this ends our lesson, and have a good day.